Greetings everybody, I'm from Tallinn University of Technology from Estonia, and in this video I'm going to talk to you something about sensor data sampling and aliasing. So, our world is analog and all the processes in our world are happening in every possible time moment. But our computers are not actually that great, measuring everything with infinite precision and in infinitely every possible time moment, because our computers are working in discrete time, and in order to them to understand our physical world we need actually converters for this thing. Those are called analog to digital converters. They take, for example, some kind of physical size and convert it into some kind of digital value that computer can read. But they are also not some kind of wonder machines, and you cannot feed them endlessly fast different kinds of values. So you actually have to settle down and send some kind of data at once. And this kind of process is called sampling. So, sampling is a process in which a certain time a data reading is taking place, and as a result we get the discrete signal to the CPU after the converter. Now in uniform sampling, every time interval t between samples is actually fixed time, it's constant, and if sample time is t, then sampling rate is 1/t unity samples per second, which is also named as hertz. For example, if we have 1000 samples per second is kilohertz. And usually the faster the sample rate, the more expensive our converter will be, and it will be also more costly for us. We also have this problem called aliasing. That means that if we sample too high frequency signal with too low sampling rate, we finally get high frequency signal reappearing as a low frequency signal. Or if we have many different functions, and if we sample them, they will give us back the same signal. So we cannot also differentiate them, which one of them was the one. But aliasing is actually quite complex and subtle phenomena, but we have a solution for this. This is called Nyquist-Shannon theorem. This is actually a really complex theorem. It's about Fourier transforms, etc. But we also have little rules of thumb for this. And it basically says that if we want the maximum frequency f to be saved without worrying about aliasing, then the sample rates will be at least double of that. All frequency lower than f will not be aliased. For example, if we sample a sinus signal at 2f, we will get back silence. So we have to increase our sample rate just a little bit. And that's how Nyquist frequency is called the maximum frequency you can sample at given sample rate without worrying about aliasing. And basically that's it. Thank you for listening and have a good time.